Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 9B. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held day before yesterday in Jaipur, India, and the virtual event is being held through Zoom today and yesterday, that is 16th and 17th of December 2025. I hope you'll enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. I request all the participants to keep themselves mute while the others are presenting. Also, kindly adhere to the timeline so that we can conclude the session as planned. I also request everyone to kindly take care of your presentations and your network error so that there are no delays, as well as keep connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Yogesh Mali. Dr. Yogesh Mali is a research dean at Ajinkya D.Y. Patil University, Lohegaon, Pune, India. With 15 years of academic and research experience, he specializes in cloud computing, machine learning, artificial intelligence, big data, and Internet of Things (IoT). He is actively involved in advancing research and fostering innovation in emerging technologies. Thank you so much, sir, for joining us. Now, without further ado, sorry, before starting, I would like to request Sir to share a few words of encouragement for the participants so that we can commence the session officially. Sir, are you there? Dr. Yogesh? I think there are some network errors. All right, we will be moving forward for now. Commencing the session, I would like to request the first participant, Sir Sanchit Sai Nipanikar, to kindly present his paper titled A Lightweight Multimodal Vision Language Model with a Frozen Vision Encoder and 2.4B Parameter LLM SIG LP Gamma 2.4B. Do we have you here with us, sir?
Yeah, I'm here. I can start.
Yes, you can share your
Okay.
screen.
Okay, all good to go?
Yes, you can start.
Okay. So, good afternoon, panel. I'm Sanchit Saini Panikar. I'm from final year student from VIT Pune, and today I'll be presenting our research work, which is a lightweight multimodal vision language model. It consists of two parts, an encoder and gamma 2.4 billion parameter LLM. So, I'll be discussing these points in today's presentation. This is the agenda for today. So starting with the introduction. So what is our research? So we are presenting a lightweight multimodal AI, which is capable of processing both images and text. So the model integrates SIGLIP 400 million as a visual encoder and a GEMA 2 billion decoder-only language model. It is specifically designed for low resource and the compute constraint environments. The proposed system supports key tasks such as image captioning and the visual question answering. So, why there is a need of lightweight multimodal system? So, recent language vision models achieve a strong performance by brute force scaling the model size. They just increase the number of parameters in a model, and they are generalized, and they are not good in a specific task, and the LMs may hallucinate. So to give an example, I have shared one DeepSeek model which was developed by China, demonstrate that the efficient design can outperform or match large LLMs such as GPT-4o on some of the structure reasoning tasks and the baseline benchmarks. So this included instance where DeepSeek model performed with fewer compared to fewer large LLMs they on the counterparts such as maths or the reasoning evaluations, underscoring the model scale is alone not sufficient for stronger performance. This shows that the model only the model scale alone is not sufficient for stronger performance. So what is the research gap? So these are the some of the existing baseline work which has already been done. So which I discovered them during our literature review. So these are the all the vision language foundation model. The very first is CLIP or the contrastive learning image pre-training model was the base model foundation model which was developed by OpenAI. This included dual encoder model with one vision encoder and one text encoder. The good thing about this model was or the strength of this model was it was good at zero shot performance, but it couldn't generate text as it was a retrieval based model. The second model I would like to explain here is foundation model is Flamingo, which was developed by Google's DeepMind, was one of the first large-scale multimodal model, which has a frozen encoder and a 70 billion parameter LLM. This model introduced a cross attention to inject visual information to LLM, but this was large and computationally expensive. So I'll just briefly explain the system architecture. So as you can see, there are two models. First one is Siglip vision model, and the second one is a decoder model. Let's say the input to the vision encoder model is an image. Let's say this image is 256 by 250 pixels. Traditionally, CLIP would have processed the entire image in a single batch, but instead, a SIGLIP does what is does is it divides the image into patches. These patches then are converted into a feature vectors V. So these feature vectors V, which cannot be directly processed by a decoder, they need to be converted from a one feature vector V to a higher dimensional vector embedding. So we have a linear projection layer. We have trained this linear projection single layer from scratch, whereas the SIGLIP encoder model and the decoder models are fine-tuned. The input to the decoder model is a visual token, which is an image token converted by linear projection model. And the second one is a text token. So what is a text token? Given an input sequence by the user, let's say where is the photographer resting, the tokenizer converts these into multiple tokens. The tokens have tokens IDs, and these then the tokens and the visual or the image token both are combined into a numpy array, and then it is passed to transformer decoder. This decoder has a excuse me, the visual or the image token that is appended to the text token sequence, and then it is passed to a gamma decoder only model. The model only solely consists of a decoder blocks which auto regressively generates one token at a time. So this decoder has a self attention layer. This uses self attention layers to predict the next token based on the previous token. The previous tokens are can be the text token and the image token. So I just now said this is a simple flow of the system. An image is passed to the firstly to the vision encoder. Then the vision encoder generates the feature vector for the given patch. Then the feature vectors are converted into high dimensional vector embedding E of image. Then this E of image token is appended to the text token x1 to x0. And togetherly this sequence of tokens is passed to the decoder. So I can say there are two main parts, the vision encoder and the decoder. The KV caching you can find in any transformer. This is basic of optimization or the KV caches basis of any transformer. So as I said, any input image I is passed to a function, encoder function f of image, which then converts it into feature vector v. What is this feature vector v? This has a semantic. This feature vector v represent the semantic content of the image. So we have kept this vision encoder frozen means during our fine tuning we need not to train the entire model on all the parameter. Some of the parameters such as f of image and the other parameters are kept frozen or kept locked. Kept locked in means the weights are locked. The very next is projection layer. As I said, the feature vector produced by the encoder cannot be directly used by the language model. So to bridge this gap, we have introduced a linear projection layer, which takes in a input feature vector v, and using weights and the bias of the projection, it calculates a single visual token embedding e of image. So this projection acts as a bridge between vision and the language model. The very next part is the decoder module and the last module. So this uses a multi-head attention, and I have already briefly explained here what does the decoder model does. So E of image and the text tokens are passed to the decoder module. The decoder module calculates the attention score for each the tokens, and then the attention score decide which token will contribute to the output, and the output can be generated accordingly. So our system, we have compared it with the baseline benchmarks. First one was COCO, MS COCO, which was the Microsoft Common Objects in Context. So we obtained a 141.9 CEDAR. For any good model, the range is between 120 to 150. This was for the image captioning, CIDR, which is consensus-based image description evaluation. For the visual question answering, we use Wikia version 2 dataset, and we got an accuracy of 83.2%. And third one was counting benchmarks. It counts the number of, it tests the model's ability to count the number of objects in a given image. So these are the results. So firstly, for the fine tuning and the testing purposes, we use NVIDIA's L40 GPU, which was available in our college. So for the inference purposes, as I said earlier, for image captioning, Microsoft Common Objects in Context, and for the visual question answering, we use VQA version 2 dataset. So these are the libraries and frameworks. You can refer them. So I would like to
Gentle
conclude.
9 minutes reminder.
Okay. So I'm concluding. Overall, our system or our research shows that the efficient architectural design can a strong alternative to brute forcing. Can be a strong alternative to a brute force parameter scaling in multimodal AI systems. So, to acknowledge, I would like to thank our research guide, Dr. Sandeep Shinde, and the head of Department of Computer Engineering, VIT Pune. And also, we have to acknowledge the contributors of SIGLIP and the Gamma multimodal system from the Hugging Face Transformers. These are the references of our literature review. Thank you. If you have any questions, you may ask.
Yes, Sanchit, it was nice presentation. I have few questions for you. First question for you is what your contribution is there, because all these multimodal like gamma,
Yeah.
SGPI, all these are predefined. So, what is your own contribution to the project?
So, as I said, there are three models. The first one is vision encoder. Second one is a decoder only gamma model. So we have not only taken pre-trained model, we have fine-tuned all the models for our tasks, which were image captioning and the visual question answering. Generally, these models are of 2.4 billion parameter and trained for general tasks. So we had to fine-tune them using our computational researches for these two tasks, and we have proven that this when trained specifically for these
Okay,
two tasks,
okay.
it outperform
Okay, the second
several
question
benchmarks.
for you is for image captioning. Even I have some better models nowadays. The GPTs also are enabled to give all the captioning. So, how your model differs from that?
Yeah, the GPT is trained on 1.3 billion parameters. If you have to set up the GPT 4.0 or GPT 5.0 models, uh,
Okay.
let's say you have CPU enabled resource, your laptop, so you cannot set up it locally. You have to use it on cloud. So you are running the GPU, the GPT 4.0 on the cloud, which is deployed
Okay.
on their clouds. Yeah.
Okay. Fine. No issues. No issues. Okay. We can go for the next participant.
Thank
Thank you,
you.
sir.
Thank you,
Thank you,
everyone.
Sanchit. Moving forward, I would like to request Ma'am Namrata Jamin to kindly present a paper titled AI-driven DDoS attack detection and mitigation system. Do we have you here with us, ma'am? Is anyone else from the team present? Since there is no response, we will be moving forward. I request Sir Santosh Kumar. I request Sir Santosh Kumar to kindly present his paper titled Balancing Secrecy and Power Efficiency in Wireless Systems Using Adaptive Pre-Processing Filters. Do we have you here with us, sir?
Yes, ma'am.
All
Give me
right.
a second, I'm sharing screen.
Yes. You can share your screen now.
Yeah, is this visible?
Not yet.
Yes, it is. Please keep it in presentation mode.
Yes, sir. I can.
Fine. Perfect. You can start.
Yeah, thank you. Yeah, good evening, one and all. I am Santosh Kumar. Today I am going to present our research paper entitled as Balancing Secrecy and Power Efficiency in Wireless Systems Using Adaptive Pre-Processing Filters. This work focuses on solving a key trade-off in modern wireless networks. That is, how to improve secrecy without increasing power consumptions. Yeah, these are the contents we are going to explore in today's session. Let's see one by one. But first, abstract. Here in abstract, wireless systems constantly face a trade-off between data security and power efficiency. Most existing security techniques either increase power consumption or add significant system complexity. In this paper, we proposed an adaptive pre-processing filter, that is APPF. These results show improved secrecy capacity up to 28% improvement in the power efficiency. This makes the approach practical for energy constrained wireless systems. Here in introduction, modern wireless networks demanded two things at the same time, that is strong security and low power consumptions. Traditionally, the already existing traditional cryptographic methods increase computational load and energy usage, especially in IoT devices. Physical layer security techniques improve secrecy, but they often require additional transmit power. So the challenge is clear. We need a security techniques that balance secrecy and energy efficiency. So in problem definition, as said earlier, existing secrecy techniques require it either lacks in power consumption, that is increased in power consumption, and it adds hardware or algorithmic complexity. Methods such as artificial noise injection and beam forcing reduces overall energy efficiency. Many solutions also fail in fading channels and multi-user environments. Hence, a joint secrecy and power optimization approach is required. So we proposed our work to address this issue, that is adaptive pre-processing filter. In this, it includes adaptive filter coefficients dynamically, and it uses channel site information known as CSI, balance secrecy capacity and transmit power simultaneously. Importantly, this approach avoids heavy hardware requirements and complex cryptographic operations. Here in methodology and implementation, I'm going to explain how system works. Adaptive pre-processing is applied at the transmitter using CSI, and power is intelligently allocated between the actual data signal and artificial noise. The objective is to maximize secrecy capacity while maintaining power efficiency. The framework is validated using analytical models and MATLAB-based simulations. And also the adaptive nature of the filter allows the system to respond to channel variations and user mobility and also multi-user interfaces. This ensures stable performance even under challenging wireless conditions. Here we can see in the pipeline of our proposed model, the figure illustrates the system model of adaptive pre-processing filter framework. It shows how the transmitter, channel, legitimate receiver, and eavesdropper interact under the APPF scheme, that is adaptive pre-processing filter scheme. The design highlights the secrecy efficiency trade-off clearly. At last, coming to the results and discussion. Now coming to the end, the proposed APPF achieves higher secrecy capacity than convolutional methods, significantly reduces bitrate error, and also legitimate receiver. Energy efficiency improved by 28% compared to the artificial noise-based schemes. Here, another important observation is robustness. The framework well performed in fading channels and multi-user scenarios. This confirms that adaptive pre-processing filter scheme is not only efficient, but also reliable in real-world wireless environments. Here we can see in the performance evolution table, the this summarizes overall performance and improvements. You can clearly see the gains in secrecy, reliability, and power efficiency when compared to the existing techniques. At last, conclusion. To conclude, the proposed APPF effectively balances secrecy and power efficiency. Security is improved without increasing energy consumption. And also, the approach is suitable for 5G, beyond 5G, and IoT wireless networks. In future, we are planning to integrate machine learning for adaptive parameter tuning and also exploring real-time and hardware level developments. These are few references we kept here from our research paper. Thank you.
Okay, just go to your architecture.
Yes, sir.
Fine. Can you put it on full screen mode?
Yes, sir. This figure illustrates the system model for adaptive preprocessing filter framework, sir. It shows how the transmitter, channel, and legitimate receiver and eavesdropper interact under the APPF scheme.
Okay. My question for you is how you can relate your work with the literature review.
Hello?
Should I repeat my question?
Yes, sir. Your voice is breaking.
Yes. Please let me know how your results are related to
Yes,
the
sir.
literature review.
Yes, sir. Sir, as I said previously, already existing traditional cryptographic methods are which takes more computational load and more energy usage, sir, compared to our model,
You
especially in
you
IoT
have not
development.
shown any comparative analysis.
Yes, sir.
Okay, this is compared to your literature review.
Yes, sir. Yes, sir.
Okay,
We are over.
sound to noise ratio SNR showing 15, right? In the
Yes, sir.
last.
Yes, sir.
So from where you calculated that?
Yes, sir. Hello?
Yes. Please speak.
Yes, sir. We took some benchmark data sets like simulation based data sets and system parameters like that, sir. For that, we used MATLAB based simulations and analytical channel modeling simulations, sir. From those, we took
Any
comparisons.
sample data sets are shown in PPT?
Yes, sir. Due to I have got only 10 minutes, I didn't put that, sir. I
No
just
issues, no issues.
explained briefly.
Okay, no problem.
Yeah, sir. Thank you.
Priyanshi, we can go for next participant.
Thank you, sir. Moving forward, I would like to request Sir Abhijit Dey to kindly present his paper titled Brain Tumor Classification in MRI Images Using Multi-Head Attention Enhanced Convolutional Neural Networks for Smart Healthcare Systems. Do we have you here with us, sir?
Yes. Good afternoon, everybody.
Good afternoon, sir. Yes, you can share your.
Am I audible?
Yes, you are.
Yes, sir, you're audible and your screen is visible. You may start.
Yes. Mm. My name is Obhijit De, and my co-author name is Mohammad Abdul Alim Sheikh, Sayok Sannal, and Tausi Banwar and Kuntal Mitra. My topic is brain tumor classification in MRI images using multi-head attention enhance and convolution neural network for smart healthcare system. My paper ID is 133. These are the contents: introduction, objective, research innovation, methodology, research analysis, and conclusion. In case of introduction part, brain tumor diagnosis is difficult to heterogeneous tumor structure and dependent on manual MRI interpretation. So we are use here deep learning, particularly convolution neural network, provide for faster and more accurate automated tumor classification. And we are using here attention mechanism to improve CNN performance by focusing on key image region and enhance accuracy for clinical interpretability. Our objective to develop enhanced brain tumor classification framework by integrating multi-head attention mechanism to pretend CNN architecture and improve the diagnosis accuracy. We are using CNN model VGG16, VGG19, mobile net, exception and inception on multi-class MRI brain tumor. To improve the model interpretability, we are applying expandable AI technique that identify, visualize the MRI region to influencing the classification decision. Our research innovation is the multi-head attention mechanism integrated into this 5 architecture, and database balancing. We are taking 22,848 MRI images and oversampling and creating balance sheet of 25,520 images across the 4 tumor category: glaucoma, pituitary, and no tumor, and meningioma. Our reference, we are taking data from Kaggle. The reference link is given here. Now the methodology. In case of our experiment, we are using data augmentation, and we are simulate these 5 models simultaneously in architected design and training optimization purpose. After that, we can evaluate the result as shown in next slide. The dataset description is preparing. We are already said this. There are different view for no tumor purpose, pituitary gland, glaucoma, and meningioma. There are top view and as well as others view, side view of the pictures. In case of multi-head attention, we are using mainly attention integrated portion, integration of attention after CMS backbone exact the spatial feature map multi-head attention module, reshape this map and compute the attention. Attention means the particular focus on that point, and weight using the learn query key value transformation. And we are taking the Adam optimizer with beta these beta values, and learning rate is 0.0001 with exponential decay. The batch size is 32. This is our evaluation methodology. In this case, recall that true positive value, and by true TP is already shown in this methodology, equation number 1, 2, 3, and 4. In this case, TP is the true positive, Fn is the false negative, and Fp is the false positive, and Tn is the true negative. True positive means when the disease happened, the result is showing there. True negative means if there is no disease and result showing that that it is no tumor or no disease. False positive means it is falsely positive and result is shown. Actually, no tumor is happened, and false negative is the vice versa. Now, the detailed result analysis, in this case, we are taking 5 different model. First হচ্ছে VGG16, that is the in odd number rows. VGG16, VGG19, mobile net exception and inception. After that, we are use the same model with plus attention. That is using expandable AI. And the row number is the even number rows. That means 2, 4, 6, 8, and 10. We get the best result for mobile net attention, that is 97% accuracy. And the bar chart for best result is shown in 6, that is the mobile net with attention. And these are computational efficiency matrix. We are here, the shown for mobile lens is the best among these 5 result. We get this. Our future direction, we will try to implement this in mobile network. That means hardware based implement that is, and the framework combined with T1, T2, flyer and DY images modality purpose. And in conclusion, the research demonstration and attention enhance the CNN achieve the radiologist level performance, 97% accuracy, while the providing interpretable, efficient and accessible drive. These are our reference. We are using in this case mainly reference number 1, 2, 3, 7 and 16. Thank you.
Okay, Abhijit sir, there are few questions.
Yes.
First question for you is, you have taken the data set from Kaggle, right?
Yes.
And applied to your CNN models, right?
Yes.
And got the result which you are presenting.
Yes.
Whether you done any pre-processing with that data?
Yes, some pre-processing. We are oversampling the data.
Okay, that's why the results are shown so good. Now the second question is, why don't you try your own contribution with some real-time data set?
We'll do it later.
Sir, when later?
Our work is just started a few months back. We'll do it later.
Fine. See, sir, when any research paper is to be presented in a Springer type conference, you should be very clear
this is
about
my
that.
first presentation in my life.
Okay. But see, this is just like students doing experiments from downloading the data with the data sets and applying the CNN algorithm, which are predefined already. So research is lacking over here, right?
I will develop next time. This is my first time in my life. I will do it next time.
Okay, fine. Okay,
thanks
fine.
for your advice.
Priyanshi will go for next one.
Yes,
Okay,
sir.
thank you.
Thank you, sir. I request Ma'am Sarabjit Kaur to kindly present a paper titled Energy Efficient Schemes for Wireless Sensor Networks, a Survey. Do we have you here with us, ma'am?
Yes, ma'am.
All right.
I will share my screen first. Okay.
Yes, please.
Good afternoon, sir. Good afternoon, ma'am. Today's my topic for my paper is Energy Efficiency Scheme for Wireless Sensor Network is a survey. My paper it is 190. These are the content of my presentation. First is introduction to wireless sensor network, and next introduction to IoT data aggregation and its technique, study and analyze the various energy efficiency protocol of wireless sensor network based on IoT, and literature review, comparison of existing approaches, conclusion and references. Now first is wireless sensor network. A wireless sensor network is a group of small wireless sensors that are placed in different location to collect and send the data or transfer the data. This is designed to monitor the physical environment like temperature, sound pressure. Sensor nodes are distributed randomly across the location that will collect the data from using sensing or connections, and data collecting is wirelessly transferred to the central location, that is sync node for processing. Next is what is an IoT? IoT, a network of physical object like devices, buildings, vehicle that are embedded with the electronic software sensor that collect the data from the different objects and exchange the data. A thing can be anything in the internet, like a person with a hard monitor implant, a water purifier, and an air condition, etc. IoT is a combination of three things, that is sensor, connectivity, and people and process. In sensor, sense the surroundings and get the information. Connectivity, we can communicate by using Wi-Fi and GPRS or some other mechanism to connect. People and process mean the collected data need to be processed and get the meaningful information for a further decision. These are the so IoT is called a combination of these three things. This is an example of IoT, Internet of Things, that smart vehicles, smart lights, smart cameras, smart building. These are some examples of IoT. Now, what is in a data aggregation and its technique? The data aggregation is an approach through which data is collected from the sensor node and transmitted to the sync node. Data aggregation also help to process and to avoid redundancy and save the energy. It helps to increase the lifeline of network. And there are main three techniques of data aggregation. First one is centralized approach. Second one is tree-based approach. Third is cluster-based approach. In centralized approach, in this method, each sensory node select most powerful head that will collect the data from its neighbor and send to the data packet via shortest possible path to the sync node. And in tree-based approach, tree is a formed first form known as a data aggregation tree. From each transmission, minimum spanning tree is creating where data, how to data sent to the sync node. Next one is a cluster based approach. In this, we have in this approach, the network is
টেম্পারেচার
divided.
সার্ভে রিপোর্ট আর এটা আমার এই টপিকের উপর, তাই তো?
In cluster-based approach, it is the most efficient approach where network is divided into two clusters, and where in each cluster we select the cluster head that collect the data from the nearby nodes and send to the base station. This is a benefit and comparison of cluster-based approach. In cluster-based approach, it is creating individual level and select process depend on, we can select the cluster head using different parameters like the distance, delay, energy level, and the temperature of the IoT device. In tree-based approach, a small change in the data causes a large change in the structure for decision tree, causing instability. In centralized approach, it suffer from the problem of high transmission, and also towards central node due to large, it suffer from the problem of the high traffic towards central node due to the large number of messages being transmitted. That will also use the more energy. Now we have studied the difference energy efficiency protocol of wireless sensor network based on IoT. First one is a LEAD, low energy adaptive clustering hierarchy. In this type of hierarchy protocol, most nodes communicate with the cluster head. Or next one is a Pegasus, the power efficient gathering in sensor information system. In this, it is a chain-based protocol and upgraded of leech version. It increases the lifetime of each node by using collaborative techniques. Next one is a TEAN, that is threshold sensitive energy efficient sensor network. This protocol designed for situations where sudden changes in the parameter being measured are to be reported. Next is APTIN, Adaptive Threshold Sensitive Energy Efficiency Network. This is the up version of TEAN protocol, and is goal at the both taking periodic data collective and relay replying to time critical event. Next is DD, that is directed diffusion. It is a data centering routing protocol for collecting and publishing the information in wireless sensor network. Next is what is the low adaptive clustering hierarchy. In this protocol is used to help us to select to create the clusters. It is a cluster, so we can. It is a cluster-based protocol in the wireless sensor network. In this type of hierarchical protocol, most of the node communicate with the cluster head. Then cluster head transmit data to the base station, and base station. And this base station is fixed and away from the sensor node. Least minimize the energy especially in the sensor networks. It consists two parts. First one is the setup part where we have cluster head are chosen based on the energy and the distance from the base station. And next one is the steady state phases where the cluster head is maintained, where data is to be transmitted between the nodes using TDM data time division travel. The next one is the R literature view, and here we have study the paper like H. Louis on a structure protocol of UAV wireless sensor network in 2024. They proposed the protocol UAV assisted wireless sensor network to address high energy consumption and premature sensor node failure in existing protocol. Outcome of this paper is to reduce the energy and minimize the node failure and prolong the network lifetime. Next one is a SSL chain. They introduce the chaotic reptile search approach protocol that will help us to save the energy in the wireless sensor network. This will help in minimizing the energy consumption, maximize the number of active nodes, increasing packet delivery to the base station. Next literature review is by S. Kavisaran. They develop a multi-objective routing protocol for wireless sensor network using adaptive Remora optimization to select a cluster head. The
Madam,
protocol.
come to your own contribution part. Just keep the
Uh,
literature.
yes, sir.
Madam, Madam,
Yes,
core
sir.
madam.
हाँ जी मैम हाँ जी
Sorry
sir.
to interrupt. Please go to your core model where you have done your own contribution.
Sir, this paper is based on only research. Like I have studied the number of papers for my further work.
Okay, that means you have only done the survey.
Yes, sir. Yes, sir.
Fine.
So I have read
Then
number of papers and use the techniques.
okay, come to the conclusion.
This one is the conclusion. Energy
Fine.
efficiency. We using study this approach. We
So what? Okay. So questions for you.
yes,
So
sir.
what, according to your survey, Leech, Pegasus, Teen, DP, or your AP Teen, which was the best?
Sir, which one is the best?
Leech.
Yes, sir.
Why?
That because this protocol help us to create a cluster and help us to choose a cluster head.
Okay. And what about Pegasus?
Sir, in Pegasus we this is also better but less than the leash, because in this we have uh, uh, this will use more energy to create a cluster and for data transfer.
Okay, fine.
Thank you, sir. Thank you.
Priyanshi, we can go for next.
Yes, sir. Moving forward, I would like to request Sir Deva Ketuts Satriyavan. I'm sorry if I pronounced that
Yes,
wrong.
I'm here, madam.
Hi. Can you please
Hi.
present your paper titled Ionic
Yes,
View Based
wait a
Mobile Computing
second.
System? Yes.
My screen showing.
Yes, your screen is visible. Please
Okay.
start.
Okay, good afternoon, distinguished delegates, represented session chair and fellow researcher. My name is Dewa Ketut Satriawan Suditersnejaya from Department of Computer Science Postgraduate Program at Universitas Pendidikan Ganesha, Indonesia. I am honored to present our research entitled Ionic View-based mobile computing system designed for urban area. This work represents a collaborative effort with my CO author, Maria Agus Oka Gunawan, Maria Santo Gita Karma, Maria Agus Gurawan, and Mr. Gede Indrawan. Let me begin by addressing the critical context of our research. According to the World Health Organization, air pollution causes approximately 3.3 million premature deaths annually worldwide. This places air quality monitoring as a matter of significant public health importance. However, traditional air quality monitoring stations face several fundamental limitations. First, they require substantial capability investment, typically ranging from 50,000 to 100,000 US dollar per station. Second, their coverage is sparse, often limited to only major urban center. Third, public access to real-time data remain restricted. The rapid advance of Internet of Things technology and cross-platform mobile development framework present a significant opportunity to address this challenge through innovative approach. This brings us to research gap and our objectives. While numerous IoT-based monitoring solution exist, there remaining a notable absence of comprehensive mobile computing system that achieve cost effectiveness while providing genuine cross-platform accessibility. Our research addressing this gap through three primary objectives. First, to design a cross-platform mobile application architecture utilizing the Ionic View framework with a microservice backend. Second, to develop a real-time IoT data integration layer capable of handling sensor data from distributed smart pools. Third, to evaluate the feasibility of achieving significant cost reduction and code reusability while maintaining application performance standard. Our research methodology follow a systematic three-phase design approach. In phase one, requirement analysis, we conducted stakeholder interview with environmental agency and public health official. We performed a technical feasibility assessment and identified functional and non-functional requirement. Phase two involved technology evaluation. We are conducted a comparative analysis of cross-platform framework. As shown in the table, we evaluate React Native, Flutter, and Ionic View against key criteria. Ionic View emerged as our framework of choice due to its web standard technology using HTML, CSS, and JavaScript, Vue.js reactivity system, extensive component library, and progressive web application support. Phase 3 focused to architecture design, where we design both the microservice backend and the smart pole hardware specification. Allow me to present our three-tier microservice architecture. At the top, the presentation layer encompasses our mobile application for iOS and Android, the web dashboard for administrative function, and the progressive web application for cross-platform accessibility. The application layer consists of dedicated microservice as authentication for secure access control, processing for data transformation, analytic for insight generation, and push notification service for alert. The data layer employ a polyglot persistence approach, MongoDB for document storage, InfluxDB for time series sensor data, and Redis for caching and session management. Our design principle emphasizes independent deployment capability, horizontal scaling, and fault isolation. The backend stack utilizes Node.js with Express RabbitMQ for message queuing and OAuth 2.0 with GWT for authentication. Critically, this architecture enables 90% code reusability across all platforms. Now let us examine the hardware component of our smart pole design. The core controller is the ESP32S3, a dual-core processing operating at 240 MHz with integrated Wi-Fi and Bluetooth capability. For environment sensing, we integrate the MQ 135 for carbon dioxide detection with a range of 10 to 1000 part per million. The PMS 5003 laser-based particulate matter sensor for PM 1.0, PM 2.5, and PM 10 measurement, and the BME 218 for temperature, humidity, and atmospheric pressure monitoring. Connectivity is provided through the GSM module, enabling cellular data transmission in area without Wi-Fi coverage. Regarding power autonomy, our solar power system employ a 6-watt panel coupled with a 3000 milliampere hour lithium polymer battery. As shown in the battery automatic analysis table, under sunny condition with 5 to 6 hours of solar exposure, the system operates indefinitely. Even under rainy condition with minimal solar input, the battery provides approximately 20 hours of autonomous operation. The communication infrastructure is built upon the MQTT protocol. We implement MQTT version 3.1.1 over SSL TLS for secure data transmission. The quality of service level is set to level 1, ensuring at least one delivery semantic. Keep Olive is configuring 60 seconds with message interval of 30 seconds. Importantly, we utilize compression JSON pilot, achieving a 40% reduction in data size, which is critical for cellular data efficiency. The data flow pipeline process as a fellow sensor reading are collected by the ASP32 transmitted via MQTT broker, processing by our backend service and delivered to the mobile application. For data quality assurance, we implement weekly automatic sensor calibration, cross-sensor validation across distributed node, Kalman and moving overhead noise filter, and IQR-based outlier detection. This comprehensive approach ensures end-to-end latency of less than 30 seconds from sensor reading to application display. The user interface apply. The user interface designed there to establish platform guideline and accessibility standard. The application feature for primary screen, the dashboard provides an a glance view of current air quality indicate. The map view display the distribution of monitoring station with color code AQA indicator. The history section present temporal trend through interactive chart, alert configuration, all user to personal notification threshold. Our design follow material design 3 guideline for Android, human interface guideline for iOS, and critically achieve WCAG 2.1 level AA compliance for accessibility. This ensures the application is usable by individual with visual, motor, and cognitive. Let me now present our key finding and performance metric. Regarding application performance, all metric exceed our target
This is a
threshold.
gentle 9 minutes reminder.
Okay. As you see in table, app launch time is less than 3 seconds, and memory usage is less than 150 MB. It's fast, and from the cost benefit perspective, traditional native developer for 3 platform would require approximately $95,000. Our Ionic View approach reduce this $57,000, represent a 40% cost saving. Okay, this question. To consider traditional monitoring station, while accurate, requiring 50,000 to $100,000 per installation after limited real-time access and typically provide web-only interface. Commercial IoT solution reduce cost to 10,000 to $30,000, but even provide limited platform support and achieve only 30 to 50% code reuse. Our system distinguishes itself with the per node cost of 500 to 1,000 US dollars, sub 30-second latency, comprehensive iOS, Android, and web support.
I'm sorry to interrupt, but I request
Okay.
you to kindly conclude because you've crossed the 10 minutes mark.
Okay. In conclusion, our research has achieved three key outcomes. First, we have successfully designed and validated a cross-platform architecture that achieves 90% code reusability, while deliver 40% cost reduction compared to native development approach. Second, we have development a robust IoT mobile integration system capability of processing 100,000 sensor reading per minute with sub 30-second end-to-end latency, ensuring real-time data accessibility. Third, we have created the user-centric design that meet WCAG 2.1 AI accessibility standard for addressing both material design and human interface guideline. Their contribution address the fundamental barrier of cost, accessibility,
Okay,
and
fine. Okay,
time.
fine. Wait. I have some questions for you.
Yes.
First of all, we'll talk about your presentation. Your slides well nicely drafted. You must have used some tool for the same, which is seen, which is not accepted. It is least accepted. Why? Because you should prepare your slide on own. You should not give any GPT model like I guess you must have done it from Canva or Gamma. So avoid that. Second thing, you were just reading out the content. You should explain it. The slides were self-explanatory, so you should have taken the advantage of that, but that was lacking. Now coming back to your research, you have
Yes.
designed mobile module, right?
Yeah.
Okay. At the back end, how you're working with all these parameters?
I'm sorry.
At the back end, yes. How you're working this parameter? Where these sensors, etc., are there?
Okay, in the back end, the sensor, the device sensor smart pulse is sending the sensor like a CO PM2.5 temperature to the back end. The back end is built with Express with Node.js, with Express.js to sending real time to front end and mobile apps like this. Then backend is uh, architecture using Node.js with Redis and MongoDB, and actually using InfluxDB for
Okay.
real-time
Whether you
data.
have deployed it at
Uh,
your area?
Not yet. For uh, this research, this for
So have you
for
calculated those
design.
results 90%, 80%,
Oh,
etc.?
okay, okay. Uh, 90% for the wait 90% for reusability.
That only air quality, etc., which was shown in your
Yeah,
snaps.
code reusability figure is derived from our technology evaluation path, especially from the framework comparison analysis present in the table one in my of our paper. Literature-based evaluation. We conduct a comparative analysis of cross-platform framework, including Ionic Vue, React Native, and Flutter-based established research in the field, as cited a
Okay,
reference in
wait.
7 and
Wait,
yes,
wait. I'm asking you a different question. You are started reading the essay.
yes,
Better last question for you. Please answer it carefully in single one sentence. Okay.
yes,
If you have developed this particular framework, then let me know where. And if not, then say no.
yes.
Whether you have developed it,
Download it. What?
whether you have developed this, or this is
Oh,
just the raw data which you are.
develop this. This.
Where
Okay.
you have developed.
Where you're done. Can you say again? My signal is
Okay.
poor.
I will say in simple English. Okay.
Yes.
Try to decode it. Okay.
Okay.
Have you developed this particular hardware architecture, and where you have developed it?
Oh, where you developed this hardware? Okay. The hardware is uh not yet development, but
Okay.
we have designed this prototype hardware.
Okay, fine, fine. Got it, got
Okay.
it. I got the answer.
Okay.
Everything
Okay.
was your prototype. Fine.
Okay.
Okay,
Very.
no problem.
Thank you. Thank
Then
you.
she we go for next one.
Yes,
Okay.
thank you so much, sir. Moving forward, I would like to request Sir Ankit Kulkarni to kindly present his paper titled Network Coverage Prediction and Enhancement in 5G Using Machine Learning Algorithms. Do we have you here with us,
Yes,
sir?
ma'am. Yes, ma'am.
All right, please share your screen.
Is it visible, ma'am?
Um, Not yet. Yes, it's visible now. Can you put it in slideshow mode?
Yes, ma'am. Is it visible, ma'am?
Yes, it's visible. You may.
Uh, Good evening, everyone. My project title is Network Coverage Prediction and Enhancement in 5G using Machine Learning Algorithms. It is basically improvement of network coverage where the coverage is a little bit weak, and later then enhancing the coverage area where the coverage is weak. These are the contents. We will look into each. First is need analysis. In olden days, there were traditional models like Okumura Hata and Coast 231, which were very complex and were dependent on numerical calculations. And 5G networks need precise coverage prediction due to higher frequencies. So we have done machine learning models which will be adaptable to dynamic conditions, and it will give improve network coverage predictions. These are some literature surveys. First, in this paper, they have used test data and trained on various machine learning models, and they have compared it with traditional models. In second paper, we have seen that they have used a repetition mechanism. If the data is not transmitted properly, they have again sending the same data. And in third paper, they have used a hybrid neural networks models like CNN and LSTM. Coming to the functional block diagram, starting from data set, we are taking a data set from Kaggle, and then we are moving into data pre-processing. Basically, we are removing the negative values or the values which are not present. Then we are applying machine learning models. And then we are evaluating the model performance basically on MSC, that is mean squared error, and R square error. And then we are implementing small cell development on the areas where the coverage is very bad. This is the data set which we have taken. The parameters we have considered is latitude, longitude, reference signal received power, and reference signal received quality. But the important one is reference signal received quality, which will be important in understanding the network coverage. And the machine learning models we have implemented four, that is random forest, SVG, XGBoost, and linear regression. This is the methodology which I have explained in the functional block diagram. These are the machine learning algorithms which we have used. First is random forest. Basically, a random forest is a group of different decision trees that make predictions. Each gives their opinions, and then we take the majority. And XGMoost is also ensemble learning. Sorry, popular ensemble learning, which gives conventionally weak learning to create a strong learner model. And SVG is a function that best predicts the output for a given input. And these are the output. We can see on the left side of the part, there is a red line which shows the ideal value of the model, and the blue points show the predicted model, which are close means that the model is aligning with the predicted model. And on the right part of side, we can see the heat map. The x-axis and y-axis represent the latitude and longitude, and red points represent the data points. Based on the heat map, we can see that yellow and yellowish region based on higher RSRP values, and green are a little bit less. We have considered this on four machine learning algorithms. These are the results that are based on mean square error. Mean square error means the how much is the model aligning with the actual. The lower is the better, and the R square value is the accuracy. And we are seeing that the random forest performs better than the all other models. And coming to the enhancement part, where the coverage is weak, we are implementing small cells which are low power and short range for typically only 10 meters or to a few to 100 meters. The features include it improves coverage, enhance capacity, and boost speed. And for the small cells, we have taken key parameters, that is threshold, that is 0.3. If the coverage, if the coverage is greater than 0.3, then only we will implement small cell to improve the coverage. Otherwise, we will not. And these are the automated results based on the small cell coverage, where we have implemented small cell only in those areas where the coverage is weak. Coming to the conclusion, basically we have taken the data set from Kaggle and applied four machine learning models, that is random forest, linear regression, SVG, and XGBoost. And based on the table, we have stated that the random forest performs better. And to the where the coverage area is weak, we have to enhance the coverage. We have implemented small cell simulation to enhance the coverage area. Thank you.
Okay. Your first question is
Yes,
uh,
sir.
how to find the coverage is less from the given data itself?
No, sir. We are taking that RSRP value, sir. If the reference signal received power coming from the base station is greater than certain limit, sir, we are classifying it as the area is good or bad or weak coverage area, sir.
Okay. So you have worked only on the given data set through Kaggle, right?
Yes, sir.
Don't you find any real-time data sets?
Uh, yes, sir. But network parameters for finding it in dynamic locations, it would be hard, no, sir.
Okay. But who
That's
will
why we
give
have
you this
taken data.
data? Who will give you
What,
this
sir?
data?
Uh, yes, sir. Your question is correct, sir.
Hmm.
We will we will try to implement next time with the real-time data set only.
Okay. But my question is, who is going to give you the real-time data? Who are the data providers for you?
No, sir. We will only generate that real-time data set, sir,
No, it will
through
be very difficult for
some.
you people to generate all the parameters from the data set. So you can approach
Yes,
all
sir.
these service providers like Airtel, Idea, Geo.
Yes.
This is done by them. All the analysis they do. Even they
Yes,
have
sir.
all the parameters which you have.
Yes, sir.
Good to catch hold of them and use them for your research.
Yes, sir. Definitely.
Okay, fine.
Hello, I do have a question here, just one question.
Okay.
Yes, yes.
So you mentioned the various parameters as latitude, longitudes. So here I can
Yes.
say linear regression. Can I know the output, the dependent and the independent variable among the parameters the you wrote earlier?
Yes, we are only considering input as latitude, longitude, and reference signal quality, and output is basically RSRQ, that is reference signal received quality. Based on that only, we are classifying the coverage areas based on that latitude and longitude.
Okay, it's a classification problem. So what about
Yes.
if I give a outlier outside from data set?
Then only we can then also we can predict the model, but we have to train on the larger data sets.
Okay, fine.
Uh,
Okay, we can go
Thank
for the
you.
next.
Yes, sir. Thank you.
Please stop model.
Moving forward, I would like to request Ma'am Vanishri Pabalkar to kindly present her paper titled Renewable Energy Based Charging Infrastructure for Electrical Vehicle. Do we have you here with us, ma'am? Is anyone else from the team present? Since there is no response, we'll be moving forward. I request Ma'am Ira Padole to kindly present a paper titled Sentiment Mining from Social Media Platforms, a tool for real-time opinion analysis. Do we have you here with us, ma'am?
Yes, ma'am.
All right. Please share your screen.
Utkarsh, are you there? Ma'am, just a minute. My co-author will be sharing the screen.
All right.
Yeah. Is the screen visible?
Yes, the screen is visible. You may start.
Yeah. First of all, good afternoon, everyone. I'm Ira Padale from Department of Electronics Telecommunication Engineering, MIT Academy of Engineering, Pune. I will be presenting a research paper titled Sentiment Mining from Social Media Platforms, a tool for real-time opinion analysis. Paper ID is 213. This work is co-authored by Utkarsh Sharbat and Nishant Rajat and Rohan Lokne under the guidance of Prachi Rajarpolu ma'am. Next slide, please. These are the key sections that will be covered in today's presentation. Next slide, please. Social media platforms generate massive volumes of unstructured data daily through posts, comments, memes, and user interactions. This data captures public opinion and behavioral patterns, making it valuable for analysis in business intelligence, governance, and social research. Existing social sentiment analysis approaches they rely heavily on manual tagging and rule-based methods, which are slow, inconsistent, and lack scalability. The traditional tools primarily analyze textual data, ignoring sentiment embedded within images and memes, which performs significant portion of social media content. To address these challenges, this project integrates optical character recognition (OCR) and machine learning techniques to automatically extract and analyze sentiment from both text and image-based content. This motivates the development of an automated and scalable sentiment mining system capable of performing real-time opinion analysis across both textual and image-based social media content. Next slide, please. Social media users frequently express their opinion through text, images, and memes. Existing tools analyze only text and ignore sentiments in images. Therefore, there is a need for an automated and scalable system that can extract and accurately classify sentiments from both textual and image-based social media content to enable more reliable real-time opinion and analysis. Next slide. These are the primary objectives addressed in this research work. Objective 1, Sentiment model development. To design and develop in machine learning based sentiment classification model trained on a labeled social media dataset capable of accurately identifying sentiment polarity from textual context extracted from social media posts and images. Objective 2, text extraction using OCR. To utilize Tesseract-based optical character recognition OCR techniques for extracting textual information from image-based social media content, enabling sentiment analysis beyond conventional text-only inputs. Next slide. Objective 3, sentiment classification, to analyze the extracted text using natural language processing techniques and classify sentiment into predefined categories such as positive and negative. Objective 4, system interaction, to integrate OCR and machine learning components into a unified and automated system for a real-time sentiment mining from both textual and image-based data. Next slide. Several research efforts have been carried out in the area of sentiment and emotion analysis from textual data. The first study focuses on psycholinguistic profiling and trait assessment using linguistic and thematic analysis techniques to understand user behavior. While the approach provides deep contextual insights, it requires experts' knowledge and is not easily scalable. The second paper explores a deep learning based approach for emotion detection from large scale textual data. It achieves the higher accuracy using work embeddings and neural networks, but depends heavily on large label data sets and high computational resources. The third paper presents a comprehensive review of sentiment analysis and emotion detection techniques, highlighting various machine learning and NLP based methods. However, most of these techniques are limited to the to the text only analysis and do not consider sentiment embedded in images or memes. From the literature, it is evident that although existing methods perform well for textual sentiment analysis, they lack support for multimodal social media content. This identifies research gap, motivates our work to integrate OCR with machine learning for a real-time sentiment mining from both text and image-based data. Next slide. The methodology begins with data collection, where we gather social media data relevant on sentiment analysis. We use Sentiment 140 dataset obtained from Kaggle, which contains labeled tweets. Next, data preprocessing is performed to clean the dataset by handling missing values, converting the text to lowercase, and removing punctuation and noise. This preprocessing steps ensures consistency and improves the performance of machine learning models. Next slide. Yeah. After pre-processing, the dataset is split into training and testing sets in 80:20 ratio. We then train a multinomial naive Bayes model, which is well suited for text classification tasks. To evaluate the performance of the model, we generate a classification report and confusion matrix, which helps us the us to assess the accuracy and reliability of sentiment predictions. Next slide. The input image is read using the OpenCV CV2 library. It is then converted to a grayscale image to reduce noise and enhance text visibility. Optical character recognition (OCR) is performed using PyTesseract to extract text from image. The extracted text is then uh, pre-processed, including cleaning and normalization to prepare it for analysis. Finally, the processed text is passed to the trained classification model, which categorized is either hateful, negative, or normal, that is positive, based on the learned linguistic patterns. Data acquisition is the first step in building our system. Relevant data is collected from multiple social media platforms, including posts, comments, tweets, and captions. In our case, we sampled data from an Instagram user. Images, videos, and textual content are then gathered to enable multimodal analysis. For text-based analysis, textual content is directly extracted while images and videos are pre-processed to extract embedded text using OCR. Here, the data is collected from Instagram was in JSON format, which is allowed structured extraction of posts, captions, comments, and metadata. Data is carefully curated to remove duplicates, irrelevant content, and low quality samples. The acquired dataset is then labeled and organized to facilitate further processing and model training. Next slide. The tech stack and algorithm used in our project includes Python as the primary process programming language for implementing the pipeline. Text data is processed through lower casing, punctuation removal, and basic cleaning to prepare it for analysis. For classification, we use naive-Bayes algorithm to identify text as hateful, that is negative, hateful or normal, negative and positive based on linguistic patterns. For image processing, OpenCV CV2 is employed to read images, convert them into grayscale, and prepare them for OCR text extraction. Next slide. So this is the block diagram. Here the workflow begins with the user uploading an image that may contain textual content. This image can be in various formats such as JPG, PNG, or PMP. The uploaded image serves as the primary input for the system. Once the image
This is
is
a gentle
uploaded,
9 minutes reminder.
yeah. Once the image is uploaded, it is processed into OCR technology. Then OCR scans the image to detect and extract textual and information embedded. The If the text is detected, the system displays the error message promoting the user to upload a clear image on a retry process. If the text is detected, so yeah, next slide please. Directly output. Yeah. So this is our sentiment analysis tool is deployed with a user-friendly interface using a Streamlit app, allowing users to upload images and view results in real time. In our Streamlit app, users can drag and drop an image up to 200 MB. Here, the output is clearly displayed for the extracted text using a sentiment classification as and it is classified as positive. Next slide, please. Yeah. In conclusion, our automated tool provides an efficient way to analyze social media data by extracting, tagging, and analyzing relevant information. It addresses key challenges faced by investigators, such as handling large volume of data, reducing time-consuming manual analysis, and ensuring consistent results. By automating these tasks, the tool significantly reduces the time and effort required for traditional analysis. We encourage investigators and informants, inform agencies to adopt these tools as a powerful resource to support their investigations and enhance overall efficiency. Thank you.
Okay, Hira madam,
Yes, sir.
you are doing OCR and sentiment analysis, right?
Yes, sir.
Then how your model is different from the real-time GPTs, where even I can take a screenshot of any comment and I will give to the model. Model will give me all the sentimental analysis as well as OCR.
Sir, could you please repeat? Your voice is breaking.
Okay. How your defined model is different from the GPTs which are available, where I can easily put any screenshot of any review comment given on social networking platform, and I can easily do OCR. Easily, I can do sentimental analysis. Even I can understand what the smiley means.
Uh,
So, how it is different?
yeah, yes, sir. Our model is fundamentally different from the GPT based models as we can put large size data of data to analyze.
Okay,
So
but I
our
guess these are very powerful compared to your compared model.
so as it is a real time, we know we don't need subscription of GPT and we can run it locally.
Okay, subscription is other part, but I guess those are more efficient compared to your model. Second thing, what about other languages rather than English? Any regional language is used, whether you are able to do that?
No, sir. Till now we have only focused on English language.
Okay, and what about the word contradictory? Means, for example, if they are saying, I will eat an elephant, so much hungry I am. So, whether such kind of sentences are being discovered in your logic?
Sorry. Sir, can you please repeat?
Okay, there are some hypothesis sentence said by or commented by runtime in social networking platform.
Yeah.
Many
Yes,
times
sir.
it happens. For example, I am so hungry that today I will eat an elephant.
Yeah.
In that
Uh,
case, when your model is able to do the analysis.
yes, sir. It will be classified as a neutral. I was not able to explain as the time limit is too is only 10 minutes. It will be
Don't worry
classified as
about
a
time. Don't worry about time. Please
yeah,
answer.
it will be marked as a neutral.
Okay. But actually, it is a sentence which is sent with too much enthusiasm. So why neutral will come in your case?
Will be not only
Okay, please
as
work on
this
that. Please work on that.
as it will be actually not possible as it will be enthusiasm. It will be as marked as a neutral in the case of uh, the sentiment classifier.
Okay, fine.
Thank you, everyone, for joining us for this session. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026 as well. Please note that all the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I would also like to thank our session chair, Dr. Yogesh Mali, for chairing this session. Thank you so much, sir, for joining us. Here is a small token of appreciation from the team of ICTCS 2025, as well as Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence. Before concluding the session, I would like to request Sir to share any valuable words he have for the participants, and then we'll conclude.
Yes, today we have gone through many papers, uh, which were giving lots of knowledgeable assets. Was a very knowledge gaining session. At the outset, I would like to congratulate JR Foundation for again conducting this ICTCS 2025 conference, and all the very best for the other researcher. Do not stop your research. Keep on doing the same. Contribute to your nation. And Priyanshi, nice coordination. Thank you.
Thank you so much, sir.
Thank you.
Thank you so much, everyone, again for joining us. I would now like to request everyone to kindly switch on their camera so that we can take a quick snapshot and then we'll conclude the session. Yes. Thank you so much, guys. Have a good day.